Hey, so hello everyone. I hope everyone is doing fine and had a great break and are healthy. Obviously, I guess I'm ready for a remote lecture because I got a new webcam. Mm. So, hopefully, online lecture will be processed quickly so that you can see today. I'm actually recording it in the morning. So let's see how long it takes. So we're going to start. So again, assignment 3 is due tonight, to Tuesday, and Tuesday midnight. And there are really good questions in Piazza. And there's going to be another office hour today. So please use Piazza, and then like if you need, I may be able to hold extra office hours and on maybe maybe tomorrow even. So let's see how it goes. Let's see how many people submit on time. Okay. So I don't know if you guys want to see my face or not. Okay, so let's start. Today we're going to talk about some theoretical backgrounds of graphical user interface programming, and then some of the stuff that you learn already in JavaScript or web programming. And these are some like theoretical foundation of GUI. So we're going to talk about MVC pattern today and widgets and events. So before we go into the detail, I wanted to touch upon some of the patterns that I see in assignment 3. I didn't particularly cover any fundamental programming concept like for loop, like array, for loop array, function decomposition. I kind of alluded those in the specification document, but I find I thought it would be nice to give some few tips. So in general, if your code is pretty complex, one way to make it simple is to reduce indentation. So I don't know how many people did use render function or I mean, I don't know how many people use like for loop or each function to iterate over items in task array. But like either way, you're gonna have some lot of if statement. And then one way to make your code stylistically cleaner and easy to follow is to reduce indentation. So for example, here, let's say these two codes does exactly the same thing, but here in this person create a block so that like specify the condition that will make the code inside this block runs, and then this person has nested if statement. So in this case, you have multiple levels of indentation, while in this case, this person decides to do exactly the same code, like same function, but decides to escape the function whenever possible, so that this kind of works like a gatekeeper. So if this if statement is true, it's going to escape this function, so it will not pass this region. So whenever this this region of code is running, that means that this if statement was false. And in this way, you can reduce the indentation and then make the code readable. Another way is to use continue, like like I'm going to release the key later, but like you will see how I worked on assignment 3. And then I'm a big fan of continue for the same reason, because let's say you used for loop, and then like this is kind of like a hypothetical example. I don't know whether you did it this way or not, but let's say you did it this way, but this is going to increase the level of indentation, while this is going to check the opposite of what's available here. So, and then use continue, which means that it's going to go back to the next item in the queue, next item in the array. So it's, again, it like works like a gatekeeper. And then I find it is more, I guess, like the code, like, well, if your code is more readable, it means then it's readable to yourself as well, so that it's pretty useful to later debug your code and modify your code and so forth. So those two exactly, hopefully does the same thing. This is basically complement of this guy, and same as this one. Okay, so these are pretty simple programming tips. Let's move on to the actual content today. So what we learned so far is we basically learned HTML, CSS, JavaScript, and then we, like I associate these 3 technology with content, appearance, and behaviors, or like I think we used to use the term presentation. So just for the sake of consistency, I'm going to just say presentation. Yeah. And then from assignment 2, I guess assignment 1, you were able to create prototype, GUI prototype. And then we were able to create a static website from the assignment 2, and with assignment 3, we were able to create an interactive web application. So I don't know if you remember this slide. This was probably the very from the very first class. So this was what this class is about, right? Like, you know, there's a user, and then they interact with a computational system. So the computational system is this whole thing. And if I can annotate, so this whole thing is computational system. And then there's like a GUI, which is going to abstract the whole thing, like whole computational system inside, like resources like such CPU, memory, network, and input and output devices. So this is what we're learning. And then like when you create a software, because there are a lot of different, you know, complex components exist in software, you need a good way to abstract like components in terms of GUI programming. So we're going to use a model view controller. So you can replace this computational system into 3 module model view controller. So hopefully everyone heard of this model view controller, and I think I briefly mentioned in the previous lectures. So view is basically what users see and perceives, because it could be audio too, right? Like auditory display could be a thing. And then users can interact with the controller, and then that's going to interact with model. So like this previous concept, now when we actually build the software, we use this abstraction of model view controller to decompose a software into 3 parts. So model view controller is kind of pretty, it has been there for a while. So it's like a software design pattern, and software divided into 3 main components. The model is basically data, which is in assignment 3 case, the task array that is available in index.js is the model. So let me see if I can open it. Yeah, this is basically model that was given. Typically for web programming, model resides in a server, but in this case, because we don't want to deal with this backend programming, I did not. I basically put model in the JavaScript memory, which is basically the reason why whenever we refresh the page, it's going to go back to the initial state. And the view is basically user interfaces, GUI, and presentation of an app. In the case of assignment 3, the HTML generated by render task function. So I've been telling people that you should have like one function that render all the items whenever there's an update in model. And then controller is something that basically whatever that is not model, whatever that is not view, I could say that could belong to controller. Or you can say that something that a user interact with, and then that's going to change and update the data, update the model in the backend, or in our case, it's going to be task array. So all the JavaScript part, excluding the render function in our case, and event handlers, those are controller part. So you can see that so user sees view, and then they use controller, and they manipulate. A controller is going to update model or manipulate model, and model is going to update view. So it's like this is kind of like me clicking a checkbox in assignment 3, and then that's going to update the completed property of that particular task in the task array. And then based on that, it's going to render the whole HTML elements again. So in detail, to give you more specific meaning of each component's model is basically system state or data. You can say application data. So in our case, it's going to be web programming and web application. Typically data reside in web server, but a lot of the cases, data is simply something that exists in your computer. Like let's say Microsoft Word, so let's say, let me see if I can open Microsoft Word. So, like this guy. So system state is basically, you can think of current state of the system. For example, I have blank document open that has no name, that is system state, and I can type, and then it's going to have content. But also the other things are current state of this document. Like for example, right now everything is left aligned, and then if I click blue and everything that I type will be blue. So the current state of the system, especially for font color, is going to be blue. And then basically this is view, but then when I click it, controller is going to change the system state to system, like the font color to blue, which is one of the system state. What else? Yeah, I mean, basically same thing for font size. And then if I start typing, it's going to be bigger. And then even the location of scroll bar, those are system state. So whenever I interacts with it, it's going to update the viewport of the document. And then in response, the model is going to update the view, which is basically this bar moving in response to my my mouse control. So that's that. So model is like system state data, and the model should not know how to present the data to a user. Basically, if let's say I'm making italic decoration, and now model basically says probably have a state called italic, and then italic is going to be true, but it does not know nothing about whether this part should be active, like whether this part should have a darker color than rest of the toolbar. So these presentation, model does not know anything about these. Basically view and controller should take care of these two. So view is what users see and presentation of the model to users. And the view knows how to access the model's data, but it does not, and it should not know how this data means and what the user can do to manipulate with it. Controller is basically how stuff gets changed, and it listens to events triggered by the view and executes the appropriate reaction to these events. And then in our case, in assignment 3, controllers are typically event handler functions. Like when a checkbox is clicked, basically you're updating data and then access one particular task and then change the property, completed property to true. So why would you use model view controller? It is useful for simultaneous development because imagine that one has to know everything from front end to the back end. Is going to be really complicated, especially when you want to build a large scale application. So we want to be able to like develop in parallel, so multiple developers can work simultaneously on the model, controller, and view separately. So here the example is the database engineer does not need to know anything about front end design, or front end developer does not need to know anything about underlying logic or database schema and so forth, unless it is the one person who builds everything. So yeah, but you know, again, I wouldn't say like, you know, help knowing in general like what's like the database for front-end developer is going to be useful, because and then they will be able to better communicate with like other people. The other benefit is grouping. So MVC enables a logical grouping of related action on a controller together, and then views for a specific model are also grouped. So that's actually leads to the next benefit, which is good for maintenance, because of the separation of responsibility. Feature development or modification is easier. So things are grouped into its functionality. For example, let's say database does not change, but then we want a new design, and then like you don't have to worry about model or controller. We only have to worry about view. And then the other thing is models can have multiple views. And there, I'm going to show one example later. So why not MVC? Well, MVC maybe could be difficult to learn in the beginning. Like it's like a abstraction that that the programmers has to get used to. So in assignment 3, maybe it's like you maybe now you know why render task function is useful, because I don't have to worry about all the details of how to render items, like task items, in response to some changes, because I just need to call that function. But initially, it may not make sense. Like it may, you might have thought that, hey, if I click a thing, why don't I just update the thing, like just the item instead of, why don't I just update that particular item? Why do I have to render the whole thing? It's like, in that case, if you approach it in that way, it's like you are trying to do like from user event, like input event, to updating the data and updating the view in one serial action, which is basically not separating model and view and controller. So again, initially it's going to be complex. It may need some transition, because you have to think about decomposing these one thing into 3 parts. And then if you have large scale software, like navigating is going to be difficult. And then like if you use some advanced framework that has MVC concept in it, it's going to have some excessive boilerplate code to start with. It may be overkill for small web application. So assignment 3 could have been done without render function, but I would say it would have been really complex. Your code could have been really complex, and it's difficult to maintain without MVC concept. And now also developer has to communicate with other people, and they have to comply with some some sort of protocol, like whenever certain things changes in model, you have to notify all the other developers who take care of like view and controller and so forth. Okay, so there are some other patterns, like we're not going to go into detail. So the one there's like and then which there's no strong there's no right or wrong, or like I don't think there's one of them is better than the other. You can sometimes, like framework, depending on the framework, they apply different pattern. So one of them is MVP. It's basically a model view presenter, where presenter is kind of like a controller, but it has one-to-one relationship with each view. And then view and model does not communicate, and presenter is going to be kind of like a mediator between those two. So here, in this case, model view controller case, like model is going to ask, like fire events to update the view, which is in our case, assignment 3 case, it's going to be render function. But here it's going to be presenter is going to be take care of updating. So in one sense, assignment 3 could be seen as MVP pattern. MVVM is model, view, model, and view model formats data from model for presentation by view. And so these kind of models are typically, you know, it depends on like what kind of framework you use and kind of like a decision variable that you have to choose from, multiple patterns. And then like typically, if you go to a software company, they follow one of the pattern. So you just need to follow what they're using. So remember that like one model can have multiple views. So let's say this is like two different examples of online shopping mall, where in the case in the left, you can drag and drop to add items to a cart. On the right side is basically an Amazon website where you individually click an item and add to a cart. So the good thing about like model of a controller is that you can have different view, even though those two can have exactly the same model and exactly the same database. And then even the controller could be the same, like, controller meaning that event handler, although like event itself is different. Like, in the left case, it's going to be drag and drop event. On the right case, it's going to be clicking this button. But essentially, what should happen when an item is added to the cart is going to be the same. So let's say event handler function is called add to cart, and then add to cart function could be used in two different cases, two different views. So yeah, so that was a model view controller. So that's kind of like a high level structure of software pattern. And then now we're going to switch gear to the lowest possible thing that we can think about in GUI programming, which is basically widget. So widget is an object. It comes from object-oriented programming. So it's like a OOP object for GUI. And it is an object-specified object-specified set of functionality aimed at both user control and at being in a toolkit. And it encapsulates the functionality and properties, and it has visual interface, handles input, and does some semantics. What do I mean by semantic is what happens on input, other state changes. So, for example, whenever I click this radio button, it's going to create this dot inside this circle. That's kind of like what should happen. Although like there's certain other things should happen, right? But widget itself has some semantic as well. And it's going to talk to the external module, external process to make some changes to the model and so forth. Or maybe some adding an item to database in the web server or something. So these are some examples of widgets, like, it could be button, it could be checkbox, it could be label even, drop-down menu, radio button, the tabs, what else? Password input, date picker, slider, another types of slider. This is kind of knob. I guess this is a progress bar. And you can have a table and text edit, text area, and so forth. So any kind of interactive object and even any HTML element could be seen as a widget, I would say. So in general, like widget is typically, like when you say widget, like you think of widget like that you see on the iPhone screen or Android phone, but that's kind of like a very complex widget, but in general, in GUI, widget is basically the any kind of interactive, or not even, it doesn't have to be interactive. Like, for example, labels are not interactive, right? So these are all widgets. And then everything, like, GUI is composed of widgets. So simple widget is basically atomic unit, atomic widgets, and it cannot be split into multiple elements. In the HTML case, things like button, input, text area, those are simple widget because typically button does not contain other HTML elements. Of course it can, but typically it does not. Like, button does not have 2 buttons inside of it. And it's reusable. And these are some examples of simple widgets. Container widget is basically widgets that can hold other widgets. So in parent-children relation, it's going to be parent all the time. So simple container, well, we could have a simple container, or it could have a complex container, such as grid layout or list layout. And of course, container can have other containers. It's like HTML div element. So div can have other div and other HTML elements. And container may be invisible. So here, this is Java Swing. And basically it has 2 containers. The first container has label and text field, and the second container has 3 buttons. And in this case, it's like basically C++ GUI framework called Qt, and the outer bordered line, bordered group is basically a container that contains a lot of different widgets that serves the same kind of goal, which is appointment details. Let me see if I can pause recording. Okay, so yeah, pause works well. I fixed some typos and errors. So these are more example of container widgets. Like, basically, you can see that there is one container, like this is one, another one here, another one here, but they have a different layout. Like, one is horizontal layout. Basically, it's going to place widgets in the horizontal way and distribute them in the same with same width. Grid layout is basically creating a virtual grid and then place them into each widget into each cell. But you can see that, like, this particular widgets is using multiple cells. Form layout, and then this is so this one is coming from Qt, and this is from Java Swing. So they have other kinds of layout, and you can see the title of window is the name of the layout, and then this kind of like a kinds of containers. So flow layout, box layout, grid bag, border layout, and I don't know what this is. So no layout, I guess. But this is kind of like this looks weird, but you can think of it like a Word document where on the top part, there's going to be toolbar. Left side, sometimes there's going to be outline. This is going to be a scroll bar. And then there's like a footer, which is the gray part of the window. And then it's going to use a container to lay out widgets or other container to organize the presentation of widgets. Composite widget is basically a combination of container and simple widgets for a specific purpose. And then this is close to what you thought like the widgets are, like stuff that you see in the iPhone screen. These are called widgets, I guess. But like in a traditional sense, it's the better example is kind of this kind of like a date picker. So if you look at it, there's a lot of different things that are happening. So this is text field. This is the like kind of like a drop down menu, and there's another button inside, and there's a bunch of labels in a great layout. So this is one composite widget, but it can have a lot of different things like container and like buttons and so forth, labels and so forth. Another example is this kind of color picker, where again you have a lot of different widgets inside this one widget. So when we talk about widget, one nice concept to understand is essential geometry. So essential geometry is basically indicates like the key components of a widget, like what is the key, like essential parts that you need for a widget, but not just the essential part, but also varying connection between input events on the different components and its behavior. So this is coming from, let me actually kill my screen. This is coming from this book, Building Interface Interactive System by Dan Olson. So let's say, what is the essential geometry of a button? Basically, clickable region, right? Like it, the whole button itself is the essential geometry. But like scroll bar, for example, it's going to have 5 different regions that acts different. Like, this is one thing, like this button, and then when user clicks this part, it's going to act differently. When like user drag and drop this things in the middle, it's going to behave differently, and so forth. So it has 5 different components, and each component has its own behavior, and then it acts differently to a click event. For example, this particular thing in the middle, it does not do anything to click event, right? You have to drag and drop, while all the other parts is going to respond to the click event. So essential geometry does not change no matter how it looks. So if it was a scroll bar, it's going to have these 5 different regions. So what's nice about essential geometry is that controller does not need to know how a scroll bar should look like. So basically, like whenever I click this button, it's going to move the viewport, and then it's going to move this draggable part to like it's going to lower the draggable part a little bit lower than it is now. And then controller does not need to know anything about these UI representation. But also there are certain constraints, like for example, these is draggable only horizontally, but not vertically. Like it cannot go outside this thing. And then button is not draggable, like, those little details. Typically, we do not implement everything, like implement essential geometry. It comes from the GUI framework typically, but it's understanding essential geometry is going to give you good way to test your GUI software. Like, what are the things that you have to test if you have a scroll bar? You have to test 5 different things, right? Like, so to make sure that it works properly. So yeah, so essential geometry is like the key components, and its varying behavior depending on your input events. So we have been looking at widgets. So widgets are a general concept, and it is not necessarily tied to web programming. And in web, we have been using some, input form like button or radio button or checkboxes. But there are more advanced UI or more advanced widget. Of course, you can make your own, but like there are also good libraries out there as well. So one library that I would recommend is jQuery UI. Basically, it's based on jQuery, which means that you would have to include jQuery to be able to use jQuery UI. And it could have pretty complex widgets as well. So let's actually go there and then see some of the example. And whenever you want to include something, that you would expect in a desktop application, I always come to this jQuery UI website and then just include them. Basically, you can add jQuery UI by adding CDN link, external link. Of course, you can download, but I'm pretty sure there's gonna be a way to external, like use CDN link. So let me check jQuery UI. Okay, interesting. So okay, so Google Developer provides some links to jQuery UI library. So it's going to add one CSS file and one JavaScript file. Okay, so let's check out some demos. Do we have demos? Okay, yeah, demo. Interaction, draggable, which is like a div element that is draggable. And then you can, one of the nice thing about jQuery UI is that they have a lot of different ways to customize even one element. So like this is draggable, but you can have other kinds of example where if you drag something like, the scroll is going to auto scroll with the draggable thing. Constraint movement. You can move it only horizontally, only vertically, but I cannot move horizontally. So, and then you can change the cursor position. Interesting. Droppable, resizable, selectable, sortable. But basically there are a lot of different things that you can use. Accordion, I don't know if anybody have used accordion. Date picker, you have a composite widget as well. But basically they will have some tutorial and API for all of these widgets. There's some cool animations for sure. So yeah, this is one library that is useful if you want to build more advanced. If you do not want to build like composite widget by yourself, and then you just want to use like some existing ones. Of course, there are a bunch of other libraries out there that you can utilize. Maybe semantic UI is another, I think, useful library that people use. Yeah, but which is kind of like a, you know, mix of Bootstrap and widgets. And I guess it's using jQuery as well. Anyway, okay, so that was jQuery UI. Let me check the time. So, and then once you have widget, we're gonna have like the hierarchical structure of widgets. So, and then it's kind of like a HTML hierarchy that you have in web programming. So widget instance trees consist of who manages whom, like parent and children, and then parent can have parents, children can have children, and so forth. And then you can think about it as a root node to the leaf node, like any other tree structure in programming. So in our case, in GUI programming, the root node is typically a window. And then of course, in the context of web programming, you may think HTML is the root node. HTML tag is the root node. But in general, native app application, and even web browser, the window, the rectangular region of application, that's going to be the top level node. And an instance tree is important because of the layout. Like for example, if I resize the window, and then parent container should tell everyone, like all their children, to resize or react accordingly. And then there could be some constraint, like for example, using CSS, we can specify minimum widths. So like there got to be some sort of like negotiation between parent and children, and then there are certain constraints that users specify. But without instance tree, you do not know which elements should communicate to each other and negotiate to each other. So that's why instance tree is important. And some of the functions are going to be, it's not something that we implement, it's something that are inherent when we pick a layout, or when we specify like CSS properties. The other thing is it's important for event handling, because they have a nested structure, and then like multiple widgets can all the widgets can have event handlers, and then sometimes like parents event handler and child event handler may have some conflicts. So what do we do in that case? So we're going to look at later how event propagates. So in instance tree in web programming is basically DOM tree. So DOM tree is like a document object model tree, and the root node is HTML. And then it always, not always, typically has two children. Two children, which is one is head, the other is body. And body can have multiple HTML elements, which is basically something that we see on a web browser window. So we're gonna look at event. Like obviously we have, we learn the event in the context of web programming, and then in general, event is an action or occurrence recognized or observed by software, often like causing originating asynchronously from the external environment, which means that when you click a mouse, that's the event, and then it's going to impact certain thing in the software, and then it should be handled by the software. In the perspective of event handler, event could be seen as a set of state that can be passed around, which is, in JavaScript event handler or jQuery event handler, the parameter of event handler function is event, right? There's a default parameter, right? And then that has multiple different, like multiple states inside about the event itself. For example, event type, name, the target, object, when it happened, and then some additional data. If it was mouse click, where it was clicked, if it was a key press, which key was pressed. Yeah, so one useful website that I like is called Key Info. Oh, Key Info, Key Press. So key code info. So this is basically showing the number that is mapped to each key. So if I type A, B, C, D, E, F, G, and then like event is basically the parameter that is passed to JavaScript event handler, and it's going to show you the property of key value, and which is basically the number that is assigned to this particular key, and then event code and so forth. So if I press A, B, C, D, and then if I press capital letter, which I'm going to press Shift key, and then press A, B, C, D again, A, B, C, D, and then you can see that the Shift key is pressed. I'm using right shift or left shift. It could be Alt, Command key, function key is not recognized, Control key, and so forth. So yeah, so this could be useful whenever you want to use a key press event to control something. For example, game that use keyboards. And then you want to know specific number of that particular key. Of course, you can specify, you can use this alphabet as well. So yeah, this is a good example where event has a multiple state like key, location, and which, and key code. Yeah, so why would I use event? So one of the key reasons we use event is that it's asynchronous property of it. So what I mean by asynchronous, hopefully people might have learned from some other computer science courses, but asynchronous means that it's not going to block the process. So what do I mean by that? So the opposite of asynchronous is synchronous, meaning that imagine that like, you know, I pressed a key in a keyboard and then it should display a certain key, like, you know, the alphabet in a text area. Between those two moments, imagine that computer cannot do anything at all during that moment. Oh, of course, it's going to be very short and we cannot perceive it. But if that means that like during the time that I press the key and, you know, to make the alphabet display that, make the screen display the alphabet, you cannot use all the other computer resources such as CPU or like memory. Like if that's the case, that's going to slow down the performance of the computer in general. And then you may think that that's pretty short time, but like in terms of CPU time, it's going to be really long time because it involves input and output devices, and IO devices are much slower than CPU, for example. But also, it could be much, much slower in terms of like, if it involves networking. So let's say if I click a mouse button and then imagine that the whole computer is going to freeze until a server, the program fetches the data from the server, and then server like send a response to the program, and then display the thing, like display whatever responses from the server on the screen. And then imagine the server is down, for example. That means that your computer is down, right? So that's a synchronous process. Asynchronous process is that basically, hey, I'm going to issue kind of like this signal to other process, and then let them take care of it whenever that computing resources are available, and so that it does not stop, it does not block the process. So, for example, like computers keep keep listening to mouse event, for example, and then once I press mouse, it's keep going to like monitor mouse event regardless of the behavior of that mouse click. So let's say um, I press the mouse button to download a file from server, and then let's say the file size is 1 gigabyte. And then even while I'm downloading, I can use mouse button, right? And then I can even use the computers, right? And these are all because of this asynchronicity in user interaction. So that's basically similar to these, like, let's say this is like a jQuery event handler. So when my button is clicked, so let me give you an example here, actually. So let's open a CodePen. We are recording, right? Yes, okay. Create a new one. So what I'm going to do is create a button. And then, so here's a button. Kind of hard to see. I'm going to include jQuery. And then I think whatever I type here is going to be it's going to, like, the JavaScript code will run after the document is ready, so I don't have to use document ready in this case. But let's put an event handler. So not div, button, click, function, and say alert. And if I click it, it's going to run this. But basically what I'm trying to say is that this particular function is going to run whenever possible. So let's say, how would I simulate that? Okay. So one way to create delay is using sleep. And if JavaScript has a sleep function, okay, set timeout. So So this basically this is adding function alert 1, and then I'm going to say 2. So this is basically adding 2 seconds of delay. So let's say 1 second. Or actually 2 seconds. And let's not use alert because it's going to wait for the user interaction. So basically what I'm going to do is change the color of button. CSS dot color to red. So basically what this set timeout does is it's going to call this function after this number of milliseconds delay. So 3000 means 3 seconds, but after 3 seconds, it's going to call this function. So if I do this, what's going to happen is that if I click it, let's make this button bigger. Let's margin. And height, size. Okay, so that's bigger, big enough. So what's going to happen if I click it? It's going to change it to blue. I mean, this part is going to run first, but then it's going to asynchronously call this function with this 2000 milliseconds delay. So the button is going to turn blue first, and then after 2 seconds, it's going to change it to red. So let me click it, blue and red with 2 seconds. If I make it shorter, like 10 milliseconds, and then people can see this, but it's going to be blue and red, short line and with very minimal delay. So I don't know if you saw it. Let's say 100 milliseconds. So you saw the blue part and then red part. But let's, so you got the idea in general, but let's try 0. So what's going to happen? What's going to happen is that, hey, I'm going to call this function with no delay. And then the question is, do you think it's going to change it to red first and blue, or blue first? So let's say if this guy runs first and then this guy runs, and then at the end of the day, we're going to see blue, hello. Or if this line runs first and then this line runs later, we're going to see red, hello. So let me save it. And then if I run it, we see this red, which means that even though this 0, like the delay is specified to 0, it's going to run this first, because these, like, you know, these like the process of this one, like this particular line and this particular line, in this case, these are synchronous process. In the meantime, this function call is asynchronous, which means that, hey, I'm going to tell, well, basically it's kind of like a different thread, different process to run this particular function whenever possible, which is whenever possible means that when like all the synchronous process are done. So basically, like, because this is synchronous, like it's going to change the button to blue first, and then now all the things are done in this process. Now it's going to have some spare time to run this particular callback function, and then it's going to change it to red. So again, it's going to, let me actually refresh it. Interestingly, even though the delay was 0, it's going to run this line first, even though like this line is before this one, because this function is asynchronous call. So any kind of callback function in JavaScript is asynchronous call, which means that it's going to issue this function call and then run it whenever possible, as soon as possible. Which means that you got to process the whole thing to the till the end of this function. Okay, so if you click it, that's why we only see the red and we cannot see blue. So this is kind of like a way to simulate asynchronous call, and I don't know if there's any way to make the JavaScript code sleep. Okay, wait, interesting. Oh, this is not, this like the promise is basically asynchronous one, so we cannot use it. Synchronous sleep. So I'm basically trying to experiment. But it seems like JavaScript does not have synchronous sleep function. What if I have like some large loop? I'm having to run here, obviously. So I added like a pretty large iteration, and it's going to be synchronous. So let's see. So maybe we'll be able to see blue one. So if I click it, oh, so basically it's not going to update the, you saw this blue and red change. Let me actually do it again. So because of this thing that I added, it's going to create like a additional delay in this code. And then the order of code, even though the delay is 0, it's going to try to complete the whole thing. And then once it has, once it complete all the things they need to complete, and then it's going to call this callback function. So let's see this part again. Click it. Now it's going to be it's going to be blue and then red. So even though we didn't specify any delay, because of this for loop, it's going to create this, it's going to block the process and then run the asynchronous call later. It's partially because like JavaScript is running in one thread, and then so I'm kind of like simulating in a weird situation. Okay, so this was completely impromptu thing that I did, that I didn't prepare. But let's just keep moving. So this was part of the reason, like the reason why I did this was like to show that event was asynchronous and it does not block the process. So let's say whenever you click a mouse button, imagine that while that for loop is running, like the for loop that has that I run in the example, imagine that like mouse is not usable. If that's the case, user experience is going to be pretty bad, right? So imagine that like the whole computer freeze or mouse is not working while the program fetch some data from web server, which is going to be pretty, create like a bad user experience. So we want to make things asynchronous, and that's one of the reasons why we use events. And then it also takes care of the separation of concern, because event handler could be used to multiple different events. For example, the add to cart event handler that we saw in the example, that could be used in 2 different views and 2 different events. And using event is going to be scalable to large user interface. So handling events, what happens in the actual program is that the app as a whole has a state machine, and then it's going to wait until an event happens. So there's going to be event loop, which is going to check whether the event happened or not, and then it's happening in the operating system level, not in the app level. But basically, it's checking whether event happened or not. And then whenever event happen, it's going to push the event to write app and write toolkit. And then, for example, if I click somewhere, basically it is the operating system that captures that event. And then if I click here, it's going to send that event to Google's like Chrome in this case. But if I click somewhere else, let's say if I click this place, or this place, it's going to send event to Zoom and to a different application. So, and then like app, like even the web browser, once web browser captures, receives the event, it would have to send it to particular web app, which is going to be, in your case, like in the assignment 3 case, it's going to be to-do list. And then still web browser is going to figure out which part is clicked, and then see if there's any event handler, and then call that event handler that you registered to a certain button. So yeah, that's like what's happening in this computer when a user event happens. So event handler, like this is basically a repeat of what we saw. Like it has 4 different components: event, target object, event handler, and mapping. So click is like example of event is like a click when a user click a thing, a button, and target object could be a button, or it could be HTML element, it could be a document. Event handler could be a function when, what should happen when a button is clicked. And then you can specify the mapping between those event handler function and then event and target object. So this is some example of code syntax of different languages. So this is jQuery, this is Java Swing, GUI framework, this is Qt and C++ language. But basically, you can see, even though you may not know the syntax of each language, you can guess that, oh, okay, this is button, which is target object, and then it's adding an action listener. Action probably is a click, and this is like name of the event handler function, or in this case, event handler object, because Java is object-oriented programming language. This is again connecting this button's clicked event with this object's quit member function. Again, this is like, object-oriented programming language, so it has to specify the target object as well, which has the event handler function. So any kind of event handling syntax is going to have these 4 elements. Yes, so you should be able to, you should be able to use like, event handling no matter what the programming language are. And then like these 4 concepts are always there. And we went on to talk about event propagation. So elements are hierarchical. We can think of like instance tree or DOM tree, but how does this affect events? So imagine a button has an event handler, and the container that has a button also has an event handler, and which one should run? The answer is both of them, because actually both of them are clicked, right? Like, once you click a button, and when you press the button, it means that you press the container as well. So that's there are 2 like that's basically event propagation. So, and there are 2 ways to propagate event. One is capturing, the other is bubbling. Capturing is event propagating downward from top to bottom, and bubbling is event propagating upward from bottom to up. So this is a thought experiment. So imagine that I have this code, and then all like their hierarchy. The top level element is form, and under the form there's going to be div element, and there's going to be p element, and it's going to look like this. And imagine that we're going to have like 3 event handler function, or in this case, it's basically 3 JavaScript line, 3 JavaScript functions that's going to run this alert function. So the question is, which one is going to work? Everything, or just like imagine that I pressed P. Is it going to run the whole thing, like all 3 different things, or just P? Because of event propagation, it's going to run the whole thing, 3 different things. But then in which order is it going to run? Is it going to be run from the bottom element like P and div and form, so propagate upward, or is it going to run form and div and P? So let's actually try this. So interestingly, I did not include this URL, but basically you can check. I'm going to leave the URL here. So this is the example. So if I click this P, it's going to run P first, and then div, and then form. So if I click div, but not P, it's going to run div, and then form. Again, if I click somewhere outside this div element, it's going to run only form. So you can see that like event propagates to instance tree, in this case DOM tree, and then check if there's any event handler function registered per element. So you can see that the event propagate upward, which is basically bubbling. So JavaScript, that by default is going to be, it's going to use bubbling, and then typically it's true for any kind of GUI framework. You can use capturing if you want to, like, check out this website again if you want to check out, if you want to know how to use capturing, which means that it's going to run from the top element. So in certain cases, you do want to stop propagation, and which means that, like, imagine this is the code that has two div elements. The top element is parent, the second element is child, and then if I click child, it's going to send event to the upper element, the parent element. So this is kind of like a code that I will distribute in the quiz today. And then I would like you to answer some of the questions. So basically what's happening here is that I'm adding this one event handler inside this. Let me actually annotate. Oops. So this event handler is gonna run when inner div is clicked, which is basically this guy. And then this event handler is gonna run when div is clicked. So there are two different things that are happening. There are two different div. Like this one is going to have event handler. Also, this is going to run event handler. So the interesting thing is that there are two different things. One is event propagation. So when you press child, let's use neutral color. So when you press this child, is it gonna run? It is going to run this one, right? And then it's going to create alert message, and then it's going to change its color to red, and then it's going to ask that, are you going to stop propagation? If I press OK, and then confirm, function is going to return true, and then it's going to stop propagation, which means that it's going to stop sending event to parent element, right? So now div element, like the parent element, used to have this event handler function, but it's not gonna run. So that it's not gonna change its color to blue. The other interesting thing is that this particular child element has two event handler. One that makes, oh, I used the wrong color. I should have used red for this one. Like it has event handler for inner div, this guy, but also it has event handler for div. So the question is, which one is gonna run first? Probably the answer is that whatever that you added first. So this is going to run first, and then this is going to run second, so that you will see the button will change to red, but then immediately it's going to change to blue, so you will not see the blue button. So, well, I'm not going to run this, but I'm going to let you actually run this whole thing. I added like Bootstrap and jQuery. Like you can add jQuery and Bootstrap in this setting menu. You don't have to include like an external link. You can include like jQuery and Bootstrap using this setting. But I will let you read this, run this code and then answer all the question. And then test it, like test the code and then answer the quiz question. Okay, so let's move on. Oh, okay, clear. And then in JavaScript, there's some elements that have default events. For example, even though we do not have to specify, like even though we do not specify click handler, it's going to respond to click event and then navigates the browser to a new link. And then input type submit inside the form document, a form element is going to submit the form to URL that are specified, which is kind of like a thing that happened in the assignment 3 that I asked you to use this preventative default. Because its default behavior is to refresh the page. So we can cancel these default behaviors by using prevent default in the similar way that we were able to stop propagation using this stop propagation. The order of running, like if default is not canceled, the event handler is going to run first. Okay, so I think that's it for today. And then I'm going to create quiz right now. And then the quiz due date is going to be, let's say within 3 days from the day that the recording was released. So it's going to be due Friday. Yeah, okay. Cool. So hopefully, again, I spend much more time in the online lecture. Given that we have one last week now, I guess I'm going to keep doing this thing to cover all the things that we wanted to cover in the first place. So, yeah, so hopefully the online lecture recording works well for you. And if you have any question, feel free to send me email. If you have any concern, like post it, create a post in Piazza, either in public or private. You can even write it in an anonymous way. And again, good luck with assignment 3. And then next lecture, we're going to look at Node.js and we'll do some little bit of backend programming so that we could we could actually do some model view controller pattern with the server-side programming. Although this course is not about server-side programming, but this is kind of like something that I want to do in terms of completing the whole web programming, and people wanted to learn Node.js as well. So I think we're gonna learn Node.js, and the next assignment is going to be about Node.js, which is basically we're gonna take assignment 3 and then create a backend for the application so that you can actually maintain data across, refresh. When you refresh the page, it's going to fetch data from the server so that it's gonna keep maintain your data. Okay, so I'll see you on Thursday. Bye-bye.